There are two formulas that you can use to find the area of a rhombus. The first one is to treat it exactly like a parallelogram, because a rhombus is basically just a square that's been pushed on its side. And so if you know the vertical height, it has to be the vertical height meeting the base at right angles, and you know the base, then you can do the exact same thing as you would with a parallelogram. You can cut it anywhere, and this whole piece, if it comes over here, would then fill in the space. So the area is base times height, but the height must be the perpendicular height. So it cannot just be the slanty height, it must be the straight up and down perpendicular height. Now, the other trick that you can use, sometimes you don't know the base, or maybe you don't know the vertical height, but you might know something about the diagonals. Now, although my picture is a little bit dodgy, the diagonals of a rhombus actually meet at right angles and create four identical triangles. So if you know the length of both diagonals, let's just say this one is 10 metres and this one was, say, 7 metres, can you see that if you take this triangle here and bring it around and flip it upside down, it can fit here? And if you take this one and bring it around and flip it upside down, it can fit here. So to find the area of this space, that would just be base, which would be half of this diagonal of 10, you'd have 5, multiplied by the other diagonal. So the formula then is half of one diagonal times the other diagonal. So here, D1 and D2 are the diagonals. Now, which formula do you use? Well, it depends what you've been given. If you've got a rhombus and you've been told the diagonals, then you use this formula, and if you've got the base and the height, then you can use this formula. Sometimes you'll have a choice.